Alright, so we're told to consider the region graphed below. The arc shown is circular, and the region extends indefinitely in the y direction. So we know this arc here, this arc here, this arc here is circular, and this region that's bounded by this circular arc and this vertical line extends indefinitely upward. I don't want to shade too much. It extends indefinitely upward. Give inequalities for r and theta which describe the region below in polar coordinates. So the first thing I did as I look at this this plot is they tell us that the arc is circular, and because the arc is circular, we know if the radius here is 3, then the radius here is 3, the radius here is 3, and everywhere on this arc or circle, we kept it going. Don't worry about this side right now. Everywhere on this arc, or don't worry about this side at all, everywhere on this arc should have a radius of 3. So the equation to this arc is r equals 3. r equals 3. And since the shaded region doesn't pass this arc or go below this arc, we know the lower boundary of our shaded region in terms of r is r equals 3. Now we'll figure out the upper boundary last. And it kind of requires a little bit of everything, so I'll show you when we get there. Alright, so now how do we figure out our theta terms? Well, in polar coordinates, this line here, and think of your unit circle when you think about this. This is theta equals 0. Well, what would this be? If this was 0 or 2 pi, but we're going to say 0 this time. If this is 0, then this line here, this must be theta equals pi over 2. And, you know, if we kept going, this would be pi, and this would be pi. This would be 3 pi over 2, sorry. And then we come back to 4 pi or 2 pi, or 4 pi over 2 or 2 pi. So we have our shaded region. We have our lower limit for r as r equals 3. And we could see that this shaded region, in terms of theta, it doesn't extend below the line, theta equals 0. And it doesn't extend past the line, theta equals pi over 2. But it goes right up into both of those lines. So we can say that this graph in terms of theta is bounded by theta equals 0, this line down here, and theta equals pi over 2, that line there. So theta equals 0 is the lower boundary of theta, and theta equals pi over 2 is the upper boundary of theta. Alright, now to solve for, or to figure out what our upper boundary of r is. So we need an upper boundary for r that will never cross, that will go all the way up until this line, but never pass it. Well, how do we figure out what that is? What would be our equation for r there? And we know it's not a standard value because we can see, look at these lines here, these values for r. That's r, this is r, and that's r. That's 3 different values of r. So how do we solve for an equation that leads us to an r that always points right to this line, or always goes right up until the line that intersects at the 4 mark? Well, we know that each one of these r's must have an x value or a horizontal value. You can think of, I like to think of it as an x value, even though that might not be correct. Each one of these r's has an x value of 4. Each one of these r's has an x value of 4. And if you don't really understand what I'm saying about that, well, let's think about a light blue r there. You know, this bottom here. Well, what's light blue r x value? Well, that's r cosine theta. right? Because r cosine theta equals x. All right, well, what's red's x value? Well, red line's x value is x equals r cosine theta. And what must be true about both of these? Well, both of these has to equal to 4. X has to equal 4 in order for our line to come all the way to, or not past the x equals 4 line. So setting our x equal to 4, I'll do it over here. And what color have I not used yet? Let's go, oh, what's the yellow look like? All right, we'll do yellow. So setting our x value to 4, we get r cosine theta equals 4. All right, but we don't want our equation in terms of 4. We want our equation in terms of r. Well, if we solve for r, we get r equals 4 over cosine theta. Okay, and let's see if this works. And I'm proposing that this is our upper limit. If we see if this works, well, what happens when cosine, or what happens when theta equals 0? Well, when theta equals 0, we have cosine of 0, which is 1. So we have this r value here. Right? And you could go ahead and test this for any value of cosine or any value of theta between 0 and pi over 2, and you're going to get an r that doesn't cross this boundary right here. So now we know our upper boundary of r, and this will extend for infinity. I can keep drawing these r's for infinity, going higher and higher and higher. Our upper boundary of r must be 4 over cosine theta. So this one, oh, that's not going to work there. 4 over cosine theta. 4 over cosine theta.